So before we talked about the derivative at a point, but now we're talking about the derivative function. So the reason why I said the second definition was better is because the only difference between, right, let me go back. I said that there were two definitions and I said the second one is better because when you work at 2.2, you just replace the a with an x. So there's nothing new under the sun here. Whereas in this guy, you're kind of stuck. You can't have f of x minus f of x. That doesn't really work. So we're forced to use the second definition. Okay. So there's a couple bits of terminology. So differentiable is an adverb. I'm sorry, is an adjective. So f of x is differentiable at a. It means it's describing a property of f of x. It's like saying f of x is young, or f of x is good looking, or f of x is wealthy. You know, it's a property of f of x. F of x is differentiable. And if it's differentiable at a point, that means a derivative exists at a point. If we say if it's differentiable on the interval from 0 to positive infinity, that means it's differentiable at every point inside there. Okay. So in example 1, we're just going to use our limit definition. So it's going to be the f prime of x is going to be the limit as h goes to 0, f of x plus h minus f of x divided by h. So in this particular case, that's going to be the limit as h goes to 0. We have a square root of x plus h minus the square root of x divided by h. Hey, Aaron, you can always pass, but I have a question for you. What technique would you use to evaluate this limit, my friend? Do you have any thoughts? Correct, sir. We're going to multiply top and bottom by the conjugate. And again, how he knows that, or I assume how he knows that, is he sees the square root minus something. In fact, both terms here have a square root. Very typical conjugate situation. So this is going to be square root of x plus h. The conjugate, we change that sign in the middle to be the opposite sign. But you can't just do it to the top. You got to do it to the bottom as well. Right? So now we have a difference of two squares. So we know that when I go to calculate the numerator, it's going to be the first guy squared. The first guy squared is just going to be x plus h minus the last guy squared. This last guy squared is just x. And then the bottom, we do not want to simplify. Do not distribute. Just leave the h to the side and then write the square root of x plus h plus rad x. Oh, shoot. That needs to be in blue. So what do we see happening here? We see that the x and the minus x cancel each other out, right? So should I write another line? We'll write one more line. Now let me shrink this down a little bit. So after we cancel out the h's, we get this. I mean, we cancel out the x's, we get this from the numerator. So then we can see that the h in the numerator, the h in the denominator are going to get canceled out. So that means you're just going to have a 1 on top here. And then we're going to take the limit as h goes to 0. So this thing under the square root, that goes to 0. So we're going to end up with, once we take the limit, 1 over rad x plus rad x which is equal to 1 over 2 rad x. This is our derivative function. Is there any questions about this? No questions. Okay. Are there any people here that have taken calculus before? Maybe you took AB in high school and you got a 3 or something like that. I don't know. Is there anyone here that knows the easy way to do derivatives? Okay, so some of you do know the easy way. I just showed you the fourth standard, which is using the definition. So when I'm testing the fourth standard, you can't use the easy way. Does that make sense? So I'm gonna have a question where I make you use the definition. And if you got the answer using the easy way, you're not gonna get credit for that. Not for passing that particular standard. I plan to teach you the easy way next week, but for the purposes of testing the standard, you have to use the definition. So use the easy way to check your answer. Like, okay, I'll leave it at that.